G'day guys, today we're going to learn how to build an MP3 player that can play up to 200 individual sounds, and at the same time we'll learn about using the Arduino Keypad Matrix library. The things we're going to cover are multiplexing signals to get more inputs with less I/O, using the voice module, the DFR0534 MP3 player, using a matrix keypad, and how to extend battery life by using sleep low power modes. So the project has two main parts. We've got this top board up here, which is the MP3 voice player, and that's sitting on a header which connects us to an Adafruit Feather 328. We've also got an external DC charging socket and some other bits that we'll go through as we solder it all up. Sitting underneath the DFR0534 is this header pin, which it's a little bit of a rough job, but once the board's on top you can't see it. I've connected 3.3 volts from this rail here, ground from over on this rail, and I've looped my serial into some external pins. Now the reason I've done that with removable headers is when I'm programming, if this is connected up, I can't program anymore. So it's an easy way of unplugging should I need to do any changes. Down here we have 7 pins that are used for our keypad connection, and we have a 5 volt input which combined with the ground over there gives me my DC input, and then here is my reset pin, which is just in case something goes wrong and we need to reset it once it's all inside a box. Now looking at the individual components, the Adafruit Feather is one of my favorite basic microcontrollers. It only runs on the 80 mega 328p, but for a lot of what I do it's enough. And the thing that I like about it is it has this little breakout area where we can do our own small amount of prototyping, but the battery charge module on board, but we can just plug a LiPo straight into, is what really draws me to this module. And it also has battery voltage monitoring built in, so I can give a warning once the battery starts to get low. The other module that we're using is the DF MP3 player. Now I had used another one prior to this, but I had some problems with it. This particular one here, it's only $2 more, but I thought it would be good because it has an inbuilt microphone and record buttons on it. But it proved to be quite a lot more difficult to use. The sound quality on the microphone wasn't all that great, so we ended up using an external mic and recording the sounds through a computer anyway. So dropping back to this one has made setting it up and controlling it a lot easier.
Okay, so what we've just done is on this feather board we've got these two sets of 4 pins on either side. This is ground and this is 3.3 volts. So I'm basically just making it so that I'm powering up the board from below. And I'm now going to wire my TX and RX and the busy pin, which tells me when it's actually playing a message, and I'll be using them later on the board. Now for my transmit and receive pins, I'm actually using something that came with the DF robot. It has a little header, but I'm not going to use the header itself. What I'm going to do is chop a little bit of the green and blue off, and I'll make it that I can actually plug it in onto the side there. And the reason for that is it shares transmit and receive with the programming of the Arduino when we do it via USB. So if I ever need to change the program, being able to unplug it as opposed to unsoldering makes it a lot easier. Now there is an option of using a virtual serial port. I found that while that works, it causes some problems with my power save features and interrupts. So I've opted not to use that. Now you're probably wondering why I'm soldering halfway up a shaft of a pin. And there is a perfectly logical reason for that. I don't want my cables on the underside of the board. So what I'll be doing, and I'll show you this in a moment, is making it that all the cables are under there, and then I can just drop this board directly on top like so, get the pins straightened out, and it will just slide down far enough that I can solder the tops of the pins, and that will be mounted directly on there. The last pin that I need is my busy pin that says when it's speaking or playing a message. The next thing I need to do is put some headers in a few other spots. So for my RX pins, I need to put a RX-TX. I'm going to put a header here. Now, I'm not going to stand them straight up because that's going to hit the board above and I won't be able to plug and unplug them. So what I'm going to do instead is put them on the side. And you'll see I've got one that I've done earlier. So I find the best way to do this is just to lightly tin the tips and be aware that the heat runs through that wire very quickly, so you're likely to burn your fingers a bit, but you'll get used to that. A bit of burnt flesh smells beautiful. And just tin the tops of the pads. You can then place this carefully where you want it and solder one side. Okay. And once you've got it in place, you can always reflow it a little bit more from the underside if you need to. So I'll do the same for this should be an 8-way. Yep. So I'll do the same for that. I'll tin each pin a little. And I'm going to start it off at pin 4 over here. Now you don't want to leave your iron here too long because these pins like that bend very easily. So once I've got it held in place, I find it's better to go from the underside and apply the bulk of the heat there, because that way you're not heating up the plastic until the very last moment, and the solder can flow straight through and onto your pin. So we can check from this side that they've all got a reasonable amount of solder. If necessary, we can now do a quick touch-up without needing as much heat as we would have before, and just reflow it a little bit more. Alright, so the other one I need is reset and ground. Okay, so that's all of my headers in place. Last trick is to take this plug and I just chop off half of it. And this is my reset pin. So what this particular unit will be is if we turn it upside down, a mercury switch will short out, which will reset the unit. And the only reason we need a reset is it's going to be battery powered, and sometimes if it doesn't get recharged, it can go into a unstable state, and it's nice just to be able to put a reset pulse in without having to open anything up. Okay, so that is ready to go. So I've got my TX and RX, so we've made the RX the green, so that will be looped onto the TX down here, and the TX of the other board will come to the RX down here. And what I'm going to do is just put a blob of glue to hold those two pins together, put a little bit up here so it doesn't actually glue it to the pins. It just holds the two parts together. This is a brand new tube, so just getting it to flow. That's all we need, is a little dob like that. So for the next part, we're going to be attaching a speaker. And I've got these little weatherproof speakers, plastic cone. What I'm going to do is use the other half of that plug that I chopped for the reset pin, and I'm going to use it to plug into here. Now it's not quite the right size because it's designed with these two locking nuts or locking pins there, which doesn't line up. So I'm just going to chop the pin off, and that should fit into there quite neatly, which it does. Okay, and the other end I will just leave a little bit of length. I can reuse these headers for other stuff, and we'll solder that to the speaker. Now, while the speaker board does list a positive and negative on these pins, it doesn't actually matter. So we've got a positive and negative on here as well. It's really only applicable if you're connecting two or more speakers together, because you want them to be in phase. Okay, so apart from getting the metal filings off my speaker, that part's ready. So I can now connect that to that. That will plug onto that. I'm just going to do a quick test before I actually solder this on permanently to make sure I've got everything in the right spots, and then we'll solder that on. Alright, so I have myself a 5-volt power source, some jumpers to simulate my switches, put my board on top, power up, and all going well, if I apply this pin to another spot, being careful to miss the first one because that's my power in. That's better. So basically I can now play a couple of notes. These things are pre-programmed with just piano key type sounds, and it works. So next we'll talk about the programming side of it.
Now I'm going to draw your head to my input header here. Now, ignoring the first pin because that's our power input, our 5-volt power in, I've only got 7 other I/O pins. And if you were observant in the first slide, you would have noticed that we have 12 buttons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how is this possible that I'm using only 7 pins, but I've got 12 buttons that I'm scanning? Well, I'm really glad you asked. What we're doing is a keypad matrix, where we basically join our buttons into rows and columns. Now this one is actually for a 16 way, so we've got 4 columns and 4 rows, whereas in my case I have 3 columns, so I've cut off this N1, and 4 rows. Now the way it works is these rows are normally outputs and the columns are inputs. And you can see the columns, they're using the internal pull-up resistor to hold them normally high. And what we'll do is we'll turn on one row at a time. So let's say it's row 1. If this button is pressed down, the negative will pass through here and pull column 1 low, and we'll read that pin as a low, and that will tell us it's number 1. Then we'll scan, we'll turn that one back to a high, turn this one to a low, and the same. We'll scan, and if we get this button appear on column 1, we know that that one's been pressed. And likewise, while row 2 is low, any other button that's pressed we'll be able to see. Now the reason for these diodes is that if 2 or more buttons are pressed, it doesn't short out everything in that same line. So let's say that we've got currents flowing through there and up. Under normal circumstances, that would also short out all of these rows which have positives on them. So it just protects that from getting a straight short between our positive and negative. Now looking at the code, I just want to point out I've made the text very large on the screen so it's easier for you to read. I'm not personally that blind. So I want to jump straight into a library that I'm using, and then we'll jump back again. So I've given reference to this particular GitHub, which I'll just bring up. So it's basically the Nick Gammon Keypad Matrix, which is where that image I was just showing you came from. And this library does all the hard work of the scanning the keypad, and it's quite well documented. So I just want to give them a shout out for providing that library. All right, so let's go back up. So what we've got here is I've detailed the different parts that I'm using. So I've got the voice module, I've got the particular Arduino board that I'm using, detailed which pins I'm using, and I've just defined some constants. So we've got the voice busy pin is coming in on input 7, my battery voltage monitoring on A6, and I have a recorded message when the battery is low, which is message number 17. Not using the onboard LED. I'm using the Adafruit Sleepy Dog library, which is basically a way of putting your device to sleep for a certain number of milliseconds and then waking it up to save batteries. And the Keypad Matrix I just mentioned. Now the way I like to do my setups is in my void setup loop is I like to have different setups for different parts because it makes it easier to track what you're going on rather than having lots in there. So we'll scroll down to the setup keypad, and in here we have a class that's been defined, and we begin it. So it's doing the initialization of the keypad, which we'll cover a bit more on in a moment. And this part here is quite important. It sets a handler that when a button has been pressed, that will call a specific function that's one of my functions that I've defined. So the button detect will be called every time a button has been pressed. All right, moving down to this part of a setup, voice setup, all this does is sets up the serial comms to my MP3 player, so nothing more than some serial there. And the last two bits of my setup, I'll just jump to the bottom. The volume just sets the current volume output, so that can be arranged from 0 up to 1E in hex. And setup pins, I'll just come back up to that one. So my setup pins does your usual setting pin modes in and out, but although it's actually outside of this function loop, I've also got in here my definitions for my keypad matrix. Now I've got one group commented out and another group down below because I'm currently experimenting with a 2x2, but I'll just talk about this one. So what we do is we define the number of rows. So I've got 4 and 3 columns, and then we define a char, so either a character or a number for each of those particular rows and columns, and it's got to be laid out in the format that your keypad is, because this is what will be returned when I get a keypad press. It will actually send me the letter that corresponds to my button or number if you stick a number in here. And this part is telling it what pins are the physical columns and rows connected to. So this row here, sorry, this column here corresponds to pin 2, this one here to pin 3 and 4, and then for my rows this will be on pin 5, pin 6, pin 9 and pin 10. Now once we've done those definitions, we need to create the object. So you heard me before talk about this KPD. So this is where it's being defined as an object, and we pass to it all of those variables that we've created, and this true tells it that we do want to use the pull-up resistors, the internal weak pull-up resistors. Now in my main loop, I'm not going to talk about all of this yet. We'll just jump straight into the keypad scan. And what this does is it'll run a routine that if a button has been pressed, it'll call that button detect routine that I've created, and we're just going to jump into that and have a look at how that works. So in the button detect, it passes in the char, which was those letters A through to L or whatever it was, into this variable. And we use that, so I'm just outputting it for some debugging there. We use that to do a if-else statement. Now up the top here, before we go through and select a new message, I'm saving the previous message into another variable for previous message. And that's so that if a button's repeatedly pressed, so if someone's holding it down, it doesn't keep on playing the same message over and over again. So we basically go down and compare the variable that was passed in that button variable. And when we find the appropriate one, we'll set a message ID to either 1, 2, 3, all the way up to 12. I've got it up to 16, but I'm not using all of them yet. And if none of those letters have been detected, I'm putting a value of 999, which is like an error. Now, in theory, that should never happen, but it's just a fallback. I then do a battery test. Now, I'm going to jump out of that and talk about it in a minute. So we basically end up down here. So we've defined a message to play, and we have a look to see if we have a message to play and it's not the same message as the previous one, so we're not repeating a message, and it's not the error message, then we'll move through. So the message play was just this that I set to true each time that we actually have a message, so it doesn't fall into my next routine. I could probably chop that out now, but it's there from some previous work. So we clear the message play to false, and then we jump into a routine of play recording. Now, play recording, this is given by the DF robot page. We simply send a 6-byte array which has some instructions that says it's going to play. Then it passes the actual track, which I've brought in from my message ID. So you see there I've passed the message ID through. And then this is a checksum for the serial. So we set that up, we send that to the serial port, which sends it through to the voice module, the MP3 player, and we reset the sleep count, which we'll talk about more in a moment. So basically, we'll pass a message into here, we'll set it up for the appropriate serial communication format, and then we'll play it. So I've brought us back into the main loop now, and we'll go back from the beginning. So what we do is we test if the input comes from the board's busy button, which is pin 7. If that one is not high, which means that it's not currently playing a message, we're going to do a 50 microsecond delay, jump into putting the unit to sleep for, I think that's 100 milliseconds. And then when it wakes up, I've given it an extra 30 microseconds because it just didn't seem to quite respond if I started sending commands immediately after coming out of a sleep mode. So that's just basically for battery savings. If it hasn't got a message to play, if there's no buttons pressed, go to sleep. I've then got a variable which starts off as 0 of sleep count, so I'm just incrementing that. And I do a test on it to see if that variable has gone above my button reset count. Now this was to stop that repeated message if you held a button down. So I can't remember what the value of this is, but I've worked it out to be 6 seconds. So if this count gets above that, we reset the sleep count and we reset the message, which means we can then replay that same button again if they push it again or it's held down. And then we go through and scan the keypad. So the bulk of that is to put the unit to sleep for battery save and to make sure that we don't just keep on repeating the same message over and over if a button has been held. And the last part that we jumped over before was the battery test. So what we're doing here is we've got a function that checks the battery voltage. So I'll just scroll down to that. So here. And what this does is it checks, there's, as it says here, there's a analog pin. It's A6, has two 100k resistors going between ground and the battery. And that then gives us a voltage divider so we can measure the voltage on the battery. So because we've got the two resistors there, we have to multiply the result by 2 after we've read it. And then to convert it to our 3.3 volt rail, we multiply it by 3.3. And because it's a 10-bit, we divide it by 1024, which just gives us our individual readings. And we return that measurement back. So that brings us back up to here, where we say, if my voltage of my battery, so it's a 4.2 volt LiPo, if it is less than 3.5 volts, I'm then going to start giving a battery warning. So when they've pushed a button, the reason I've stuck this in the button routine is if the battery's getting low, before it reads the message that they want, it will make an announcement to say battery low, and then it will play their message. Okay. Alright guys, as this video is getting far too long, we've hit 25 minutes, I'll do a follow-up video on how we actually record messages to the MP3, which is amazingly simple. If you've got any tips on how to edit videos to make them interesting and short and give the information all in one, I'd love to hear your feedback, or if there's anything you've seen in this video that you want a bit more information on, please just post a comment below. Really appreciate your likes and your subscribes, and we'll catch you in the next one.